Hello everyone. Today we're going to go over KSP values, or the solubility products. Now before you go into this, I suggest you know a few things about molarity and all the things that are incorporated within molarity, such as the dissolving of products within an aqueous solution. And so we're going to go over this standardized chemical equation that is right here. This standardized equation is simply understood as we have A moles of compound A, B moles of compound B, C moles of compound C, and D moles of compound D. Nice and simple, right? Well, I hope so, because this next part is where it starts to get interesting. So what this reaction has, it has an equilibrium. When these arrows are going both directions, that means we're at an equilibrium state. The equilibrium state is represented by a KSP value. This is an arbitrary number related to the equilibrium. So let's say for this particular reaction, we have a KSP value of 5 times 10 to the negative 6th. That looks like a nice number, right? Right. And so what we're going to do is say that the KSP value is equal to the concentration of products over the concentration of reactants. Just remember, those bracket symbols always mean concentration. And so what we're going to look at today is molarity as our concentration. So what we're going to do is now write the KSP value of the actual products over reactants. So we have a KSP value of compound C, and then we also have C moles of compound C. C moles would then be put as a power of the concentration. And so the same goes for compound D. We have D moles of it, so it would go as the power of the concentration. And so we have now underneath compound A, we have A moles. We also have compound B, we have B moles. Simple? I hope so. Alright, so let's say that we have this KSP value up here. I'm not sure if any actual reaction has that KSP value, but it is within a range of KSP values. So what we're going to say is that this KSP value is equivalent to this reaction. And let's say that we have that little a is equivalent to 1, little b is equivalent to 1, little c is equivalent to 1, and little d is equivalent to 2. Which seems simple enough, correct? And what we're going to do now is we're going to solve for d. So let's say that we have 1 mole of this, 1 mole of this, and 1 mole of this. Well, 1 molarity of it. So each of these are at a 1 molar solution, and we don't know what D is at, what the concentration of D is in our solution. So let's figure it out. So the KSP value is equal to C, which is 1 molar, to the power of C, which is 1, and anything to the power of 1 is always equal to itself, so it's not necessary to write that. And then we have D, which is the power of 2, and then we have that over 1 molar times 1 molar. And we know that the KSP value is equal to 5 times 10 to the negative 6th. So I'm sure you can figure out what this next step is in this reaction. You simply do some math. 1 times 1, well, that equals 1. And I'm just going to keep everything written in here, even though it's a value of 1, for simplistic reasons. so that you can understand when it gets to more complex equations. So we have it simplified down to this. What we can simply do is multiply 1 to both sides of the equation and divide by 1 to both sides of the equation. So say if this was a value of 2 instead, then it would simply be multiplying 2 on the KSP value side. But right now we're going to stick with the 1. So then throughout the course of the math, we have d squared is equal to 5 times 10 to the negative 6th. Simple. And so we take the square root of each side. And so then d is equal to 5 times 10 to the negative 6th, correct? Correct. By what I've shown you, this is true. However, there is a lot more to this equation than this, because you're never going to have something as simple as this. I know you wish you did, but you don't. So I'm going to, in the next video, show you a real reaction, which you'll learn really quickly is a lot more fun, in that the math is going to become a lot more tricky. So hope you watch the next volume of this, coming at you very, very, very soon.